Um, Hi, my name is Rodrigo. I'm basically a pen tester. From time to time, I do a bit of research. And as part of my research, I do a bit of fuzzing. I like coding, so I sometimes code some tools. Some people like them and use them. One of them features backtrack and several books about fuzzing and stuff. So today I'm going to talk a little bit about fuzzing. Nothing too specific, really. Basically, I was talking to some guys before, and they were saying, well, you shouldn't assume actually that everyone knows what fuzzing is. And I was a bit shocked, actually. And it turns out that maybe it's not as mainstream as we thought. So, I'm going to talk basically a little bit about fuzzing from the very, very, very beginning to now, basically. Formally, the term fuzzing is around 22 years old, so as you can imagine, it's been a little while, and during that whole process, that whole time, there's quite a lot of changes into the approach. Obviously, the whole approach has become a bit more sophisticated during the time. I'm going to keep this presentation short and to the fact, basically. I was preparing this presentation and I was trying to look the whole fuzzing technique from a very, very high level and try to see how it evolved. And I could very easily differentiate two periods from the very early days to the last decade, which I think is, until now. And then you can kind of figure out how the fuzzing industry or technique is going to go. So I'm going to talk a little bit first about the very beginning, about the past of fuzzing. So basically, this is the first reference that I've seen to something that somehow resembles to software assurance or to fuzzing. It happened a long time ago in 1983, and that was in Apple, actually, when they were developing Macintosh. And a really cool story, actually. Basically, these guys were preparing kind of a demo so that they could put a Macintosh running an automated series of actions, right? So basically, they developed this program whereby you could feed events into that system. So basically, you could feed that the user clicks certain menu or does that or that, basically for presentation purposes. But then those guys, the first Macintosh had only like 128K of memory, so the memory was really low, and the testing was kind of important. And they thought, we could actually use this very same thing for doing kind of a stress software. So basically, what we can do is feed that with lots of different events and see how the application reacts. So they called it monkey because it looked like basically a monkey randomly pressing keystrokes and clicking on places. So this was the first reference to fuzzing, as far as I know, because it basically resembles fuzzing at the end of the day. They used this application for stressing the first Macintosh applications, and they found quite a lot of bugs, but they found that at some point the monkey would click on quit or exit or close the window, so they created a flag into the processor called monkey leaves, which is quite cool, whereby it disabled the exit function, which I think, so basically this is the very early days. I found, another example is in the fall of 1988, and this is the first time where the term fuzzing was used. It was used by Bud Miller. He was a professor in Wisconsin, and was basically providing certain assignments to the students for a course. And I don't know if you can see on the slide, but basically it's a project that this professor proposed to the students. And basically it says, well, you should create a tool that randomly generates some input and then feed that input into a number of Unix tools. And it's the first time that the term fuzz appears in the literature, basically. So basically, he called it fuzz generator. And afterwards, after asking him why the word fuzz, why not anything else, basically this is really funny. He responded that basically he was a professor in Fall in 88, and he was connected with a modem to the university from home. And apparently it was a very stormy day with lots of rain, and there was lots of noise in the line. So he had to kind of type really, really fast, hoping that the line didn't provoke so much noise that basically the whole command would be wrong due to this noise introduced on the line. And he was really surprised that actually the applications would fail just because of that noise, and that's how the whole thing started, really. So, well, basically to sum up, on the early days it was a kind of a bit primitive approach. As you can see, this lack of formal methodology, this basically was just the beginning. And one interesting thing is that software assurance was actually not security related, it was more about the stability of the software and that kind of stuff. And, well, fuzzing obviously was not a proper approach, or, well, I wouldn't say proper, basically a chosen approach for software assessment. And also, the reason why it was not security focused, it was because there was no such knowledge of the attacker. By that days, well, you could easily log on, well, SMTP servers were open and you could log on to anonymous shell accounts, so, well, basically that was it. So let's move on to talk to the past, let's talk to the present now. So it's very interesting how fuzzing actually evolved. I found it, well, I think a key event was the commercial tools appearing into the whole scheme. And in 1999 and 2001, Protos was released. So if you don't know, Protos is basically a very well-known tests set whereby you could feed certain applications with a kind of crafted input, and they were very thorough, and they discovered lots of vulnerabilities. So basically, it was the starting point of fuzzing in the corporate world. It's been 10 years since that already, and I think one of the reasons why fuzzing is so popular at the moment is because there's obviously a proven excellent ratio between the effort and the result that you get. So basically, with a very small amount of effort, you can get very interesting results. Obviously, the more effort, the better results. And yeah, fuzzing in this decade has become quite mainstream. We all know about the term, and hopefully lots of people have developed fuzzers. As in the previous presentation, the BNF fuzzing said, is not an amazing thing developing a fuzzer. It's actually a fairly simple approach, you know, and to code simple fuzzers is very, very simple. Also, the entry level is being minimized because there's now so much information, there's so many fuzzing frameworks and tools that, well, it's becoming easier. Okay. So basically, there's a clear trend towards the commercial world. Basically, the big names like Microsoft, Cisco, IBM, all of those are adopting fuzzing quite heavily actually. And it's interesting that fuzzing has been used for many different technologies actually. So not only web browsers or ActiveX or every single thing that allows certain data entry, well, it's been fuzzed at some point in history. And if not, well, it will happen very, very soon. I'm going to go through a very, very high level about fuzzing so that then the demos become a bit more clear. Basically, well, we could define fuzzing as providing a pseudo-random, unexpected entry to a system. And that entry could be in the shape of a network protocol or a file or anything, or a call to an API, a variable, any data entry could be changed. And there's different approaches to fuzzing. So one of them is mutate valid data. Right? So if you have a valid sample, then you slightly change it and see what happens and see how the application reacts. And another approach is just generate it. In order to generate it, you would need some kind of a specification. Right? I'm going to keep it short. And, well, there's another trend, which called evolutionary fuzzing. And quite interesting, basically. It's I would say a mix of the two of them. So basically, you provide a valid input, but also using what is called exploratory primitives. It tries to identify the different fields, it tries to understand the data, and then according to that, it checks the reaction from the target program, and it feeds that according to what it discovers. So basically, it evolves the matter of the way it fuzz, basically. Very, very simple. As you can imagine, we are talking about software and two different approaches, black box, white box. With black box, it's fairly blind. You don't have the code. With white box, you have the code. There's advantages and disadvantages of both. Basically, sometimes we only have black box approach because we don't have the source code, so that's the only way we could do. And some of the times we can use a white box. I'm going to demo both today and see how. So I can give you some examples. One of the main problems with fuzzing usually is code coverage. Sometimes you feed an application what you think is going to reach quite a lot of branches of the code, but actually it's not. It could be for many, many reasons. Maybe because your input was not correct, or maybe the behavior of the application, or something like that. That is usually a big problem with black box. With white box, obviously you have more understanding of the code, and obviously you can provide better input. About gray box, lots of people talk about it. Actually, if you think about it, it doesn't really exist anything called gray box. Gray box is black box, but doing it properly. It's about reverse engineering, knowing about more. It's a bit more in-depth fuzzing process, basically. Right. Just a couple of random slices, and basically just random facts and releases in the fuzzing world. Quite random, really. In 2001, Codenomicon founded. Codenomicon is a company heavily focused on fuzzing. 2002, Spike fuzzer by Dave Aitel from Immunity. Very, very well-known fuzzer, truly ahead of his time, but still one of the main fuzzers and really, really good. 2004, Mangle.me, which is an application that mangles HTML files coded by Michal Zaleski, now working for Google. Really, really cool tool to detect basically anomalies in web browsers. Pitch Fuzzer, which is quite maintained, it's a framework, etc., etc. You can read the slides afterwards. Tau also around there in 2006. The only reason this is mentioned is because I coded it really. So And also, just to let you know, just to show that fuzziness is really, really a topic that we are all is really trending now. And basically, lots. I just searched on Google in Black Hat, basically talks about fuzzing, and there were a lot. There were a lot of them. So you can have a look. I read most of the papers, and yeah, as you can see, well, pretty much everything has been tested with fuzzing. Everything, Keneland with driver fuzzing, Wi-Fi is very into it right now. Lots of presentation comparing different fuzzing frameworks, etc., etc. So let's go to the demo time. I prepared. I was thinking how I can show to someone who is not that familiar to fuzzing. How can I show a sufficient representative demo so that you get somehow an idea of what fuzzing is about. So I'm doing 3 demos with 3 different fuzzers and doing 3 different approaches. The first one, it will be network fuzzing. The second one is a whiteboard fuzzing, and the third one is file fuzzing, which is quite popular right now. So yeah, demo 1 is basically I chose HTTP DX server, that is a HTTP and FTP server, and well, I'm using Tau for exploiting and fuzzing that one. So basically, let me show you. Let me run this. So we have the server running. So it's an, as I said, FTP and HTTP server. What we're going to do is we run. That's a right. So Tau, if you don't know it, is it's a network fuzzer, and I think good thing about it when I coded is that it's extremely easy to use. Probably it's not the best fuzzer out there. You're not going to get the best results, but definitely it's the easier, and it will give you results. Okay, so it is an agnostic kind of fuzzer, so you can fuzz any TCP protocol. You can feed it with FTP, HTTP, any VNC traffic, anything database traffic. You can do anything. So basically, the way of doing it is setting up a man in the middle with the tool forwarding the traffic between the client and the server. So basically, that way the tool can learn the traffic or retrieve the traffic. This is one approach. There's other tools doing some other approaches, like, for example, reading from a PCAP file or something like that. I chose to do this because I thought it was maybe cooler. So, so we have an FTP server running on this box. So what I'm going to do is I'm going to set up the man-in-the-middle attack, listening on, for example, 2121, and I'm going to forward that to localhost on 21. Okay. So it's as simple as that. And now, so now if we go to 2121, actually we will be reaching the fuzzer, and only 5 minutes to go. This is going to be really, really, really fast. Right, so basically we are reaching the fuzzer, and we are basically doing all the man in the middle in the fuzzer, and we can access the FTP, okay? So, just to show you, really, so this is what the fuzzer learned. Well, basically I sensed this by default, but we can see that this is the user, the pass, and then all the commands that we learn. And then you can go and start fuzzing. If you think that there's something interesting on this request, you set a fuzzing point. You add it, and you click OK. And then you think, okay, I'm going to fuzz this also, so you add it. Oops, you double click on it, you add it, and it will, basically the fuzzer will replace the content on there, and it will fuzz it. So let's start fuzzing. I'm going to attach Poly Debugger to the going to attach Poly Debugger to the fuzzer, So there you go. So, oops. So there you go. It's running, and now we start fuzzing. There you go, and as you can see, there was an exception. The server becomes irresponsive, and basically this is the results of our fuzzing. If you want more details, maybe we can talk later. I'm going to crack on very, very, very fast because I think we don't have much time. So basically, as you can see in here, TAUF presents all the traffic. We choose where we want to fuzz. We click fuzzing, happy days. Okay. Fuzzer also has its own debugger, but we used. Okay, very, 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 very cool demo. This is white box testing using a really good fuzzer called by Michal Zaleski called Bunny the Fuzzer. This is a really cool example. If you can see, please do in the source code. As we can see, this is a C program, and the interesting bit is that basically if we have 0, 0 on our, well, basically we read for 4 bytes. If we have a 0, 0 on the first parameter, it goes to this function. If we have a 0, 10 hexadecimal value on the second byte, it goes to this function. 0, 20 goes to this function, and 0, 30 goes to this function, and that's an illegal allocation of memory. So this program will only and only crash if we send 4 values, which are 0, 0, 10, 20, and 30. With a mutation or a generation fuzzer, this will be impossible. What are the chances of discovering that? I would say minimal. Okay, I'm going to show you how we can do that from a white box perspective. So very, very quickly. Can you see that? There you go. So we have basically this the test.c, which is the one we tested, what I showed now. And basically what we do is we use a compiler by the fuzzer, that what it does is similar to GCC, so it compiles it, but instead of cleanly compiling, it also hooks on certain conditions. It hooks and adds some logic into the program. Okay, so basically what we would do is so we used Bunny GCC, okay, to compile the source code. Okay, so it would be demo 2. Okay, so now we have our a.out file, and now what we do is we feed. So this is the same a.out, and we have a directory for inputting information there. So as you can see, there's only a file there with a bunch of A's. There's nothing else. Okay, so the fuzzer will take that input and compute that and see how it goes, basically. So I think I have. So okay, so now we are going to the -i to the input folder, the -o to the output one, and then we execute the file. And basically what this program is going to do is execute that program and then read the hooks that it inserted while compiling it. So it would basically identify all the branches in the code. It will identify all of will identify all of the branches that I showed you before, okay? And it will go through it and then show you. It will create an output file. Let me open the. Oops. It's doing it. Sorry. So it goes through all the branches of the code. And then this is the result of the fuzzing. So it basically detected all the different branches, it detected all the different conditions, and it has created a file that actually creates a segmentation fault on that program. I don't know about you guys, but I think this is truly amazing. It's an amazing software assurance technique. Do we have time for the last demo? Chris? Someone? But until they kick my ass out of here, I will demo them. Let me show you last demo then. Very, very quickly. Basically, we have this tool is really good. We have this. So I have a file just with this ASCII art, and there's this really cool fuzzer, which basically what it does is just hooks the input-output functions, and it just randomly changes them. So instead of cat ASCII art, what we do is we execute the file. Oops, sorry. And as you can see, it executed the same thing but changing it. This is really, really cool for file fuzzing, for discovering vulnerabilities in Office, Acrobat, media players, etc., etc. And so, for example, we can see this with a number of parameters. So if we do, this will execute this command 100 times with 100 different seeds on it with different parameters, and we can use this for fuzzing, file format basically. So basically, I have here an MP3 file, and what we can do is we can try this program with to make something to break. Let me copy and paste this. So basically what I have here is fuzz. This is a limit for the memory. This is so that the exits the child 3 seconds. We are doing 10,000 tries against Totem, which is a media player, against that file. Okay, and what it does is it changes the content of the file basically, and as you can see, as you can see here, there's already some errors or some problems. So the file is a different one. As you can see, even the title is changed because that's metadata within the MP3 file. So basically, every single time that you see this screen appearing is Totem actually executing a totally different MP3 file. So basically, you can leave this running and find code vulnerabilities for the end-client exploitation and that kind of stuff. Actually, I would show you a crash, but I don't have any 0-day or any proof of concept for this at the moment. I just prepared this for the conference. And also sometimes it's really cool even listening the MP3 and see how the fuzzer changed it. Or maybe I'm a freak, whatever. So yeah, well, basically, I think a little bit. If you need a bit more explanation about all of this, because I understand this has been really, really quick talk, just grab me in the pub with ice surfer or something. So yeah, this is the demo, changing the formats and then all the problems and errors from Totem. Okay. So a little bit about the future, really. Well, not really much. It's basically what is going. It looks like it's going the fuzzing world. Is becoming really strong in the software development life cycle. Fuzzers are becoming smarter and smarter. They are becoming better and better. I can see white fuzzing as being adopted in a methodical way by lots of software companies. Yeah, there's lots of research by Microsoft at the moment doing all kind of fuzzing and doing amazing stuff also with file format fuzzing. And that's it really. Some conclusions. Basically what I said, fuzzing has been a long time and it will go longer. I can see that going in the corporate world, there's lots of companies offering fuzzing services, including mine, and so that's about it really. If anyone has some questions. Nothing? Well, thank you then. Cheers.